Good evening, everyone. It's my great pleasure to introduce tonight's guest speaker, Dr. Carika Weldon, an extraordinary Bermudian biochemist and a true pioneer in the field of genomics. Dr. Weldon is the first and only black woman in the world to be the sole founder of a genomics company, Carry Genetics, where she currently serves as a founder, CEO, and director of research. Dr. Weldon earned her Bachelor of Science with honors in medical biochemistry and later completed her PhD in biochemistry at the University of Leicester. In 2015, her academic achievements led her to become the youngest full-time lecturer in biomedical and medical sciences at De Montfort University in the UK. Her commitment to advancing science didn't stop there. In 2016, Dr. Weldon founded the Bermuda Principles Foundation, aiming to make meaningful contributions to Bermudian society through education and science tourism. Her passion for research drew her back into full-time research at the Oxford Genomics Centre, University of Oxford, in 2018. When the COVID-19 pandemic struck, Dr. Weldon answered the call of her homeland, returning to Bermuda to play a pivotal role in expanding the island's testing capacity. As the science advisor to the Premier and the lab director, she established and led the government's molecular diagnostic laboratory, a critical component in Bermuda's pandemic response. For her contribution, she was awarded the Queen's Certificate and Badge of Honor in 2020. Today, in addition to her leadership in Carry Genetics, Dr. Weldon shares her knowledge as an adjunct lecturer at Bermuda College, inspiring the next generation of scientists. Her vision is to build on the research culture nurtured during the pandemic, ensuring a healthier future for Bermuda. Please join me in welcoming Dr. Carika Weldon.
Good evening, everyone. I hope you've had a good night tonight. I almost forgot I was speaking. Got very comfortable. It was a lovely dinner. But I hope I can share what I've been up to since I finished that last gig, I'll call it, with the COVID pandemic, and talk about precision medicine here in Bermuda. So what is precision medicine? It's essentially tailoring medicine for all based on an individual's genetics. Can you look to the person next to you? Do they look like you? I'm not going to ask if they look better or worse. I'm not going to ask that. Do they look the same? No. Okay, so we all have unique genetics, both what you can see and what you can't see. And that's the key foundation to all of what I'm going to talk about. You may have heard this before. There are certain aspects of medicine that are one size fits all. That does not work for everyone. So, for example, you cannot take all of those puzzle pieces and put it into that position. You have to find the correct one. And the other real key thing is that we all vary in how we respond to medical care. I'm sure all of you here as doctors have experienced that. You cannot kind of take one solution for one patient and give it to the next. You have to really think about that individual. And there are many different factors that go into why that is, which are here, and genetic variation is one of them. Okay, so we all know about our DNA. Yeah, you got half from your mom and half from your dad. And it plays a role in many different aspects of health. So one is our risk of disease, how we respond to the environment is based on our DNA, and what medications we should also be taking or giving to your patients. So I'm going to start on the first one, which is the risk of disease, and talk about our breast cancer study first. So the burden of breast cancer is not equal. This is a fact. This is, well established. This is actually the rates from the World Cancer Research Fund. As of 2020, which is their latest dates, this is looking at the top 10 countries getting breast cancer, so the incidence on the left, and then the top 10 countries dying from it. And I've split it European versus non-European, and I've done that because most of the databases for genetics is split that way. And you can see there's a really clear distinction. It's known that more women of non-European ancestry die from breast cancer than those of European ancestry. And particularly if you look over here, can you see my... Yes, you can. If you look over here, you can see that 9 of the top 10 countries are European that are getting breast cancer, but all 10 are non-European, and 4 are Caribbean. Now I know, I'm going to establish this before we continue. I know we are in the Atlantic Ocean here, in Bermuda. But we did not come from the ocean. We came from somewhere. And we came from the Caribbean. Okay, right, perfect, established that. So I'm lumping us with the Caribbean because genetically that's where we are, where we lie. Okay, we kind of just drifted off, got lost a bit, but we all agree? Perfect. All right, so you can see the top spot is actually Barbados, which is very striking. It's a high-income Caribbean island with universal health care, which I'm not going to talk more about at all, that covers all citizens and approved permanent residents. So the question about, is it access to care? Is it, something that they're not getting kind of goes away with that fact. So this is a study that was done by a group. It spanned from 2010 to 2020. They conducted over 1,000 women with breast cancer, and they did sequencing. They did a panel, so that's where you do certain genes, not look at everything. And it was across 7 different islands, and you can see quite clearly, number one, that not every island is the same. So yes, some have BRCA1, some BRCA2, some have different ratios of them, but if you look at the whole group, actually, as was beautifully laid, I really appreciated that. I felt like he was lining me up so nicely for all the genes. 87% of these were BRCA1 or BRCA2, which is in line with what you would get anywhere else. What their conclusion was, though, okay, 87% is BRCA1 and BRCA2, but that means 13% weren't. So they said that actually we should be doing more than just BRCA1 and BRCA2 testing. That is kind of the go-to when you think of breast cancer, but there's more genes. And so for the Caribbean, we should actually be doing a multi-gene panel. Now, there has been no study to date of women of Caribbean descent for unique genetic markers related to breast cancer. All the genes I showed you have been found from European studies. So we decided to do one. We kicked it off last year. We had to wait 14 months for ethics. Yes, it was a long process. Because we're doing whole genome sequencing, it means we can look at everything. And so there were concerns initially about what if you find Huntington's disease and then that person can't get insurance. So we have dealt with that. We only have consent to look at those cancer genes. There's 30 of them that we look at, and we report back to the patient. So what is the goal? The goal was always early diagnosis by identifying these genetic markers, which may be the same or may be different. We hope to find unique markers for Caribbean women that will allow for more specific predictive screening and earlier intervention. I'm very pleased with this part. This was the biggest aim, was to keep everything here. Because for all that study that happened before, the 1,000 samples, every single one was shipped out to the US. Yes, it was. So I set out to say, we could do, when I left, we did 705,000 COVID tests. Yeah, it was a lot. We can do some genetic sequencing here. And so we did all the processing in Bermuda, at Bermuda College. We're the first Oxford 94 Technologies certified service lab in the Caribbean, and the only one that can do large-scale projects in the entire LATAM and Caribbean region. So we got that certification. Thank you very much. Very proud. We got that certification January, I think it was January 9th, and we dove right in next week with this breast cancer study. Okay, what are we trying to do in the study? We had 2 different groups. We had the patient group, which we wanted 50 women that had breast cancer. They had to be 18 years or older, and they had to have 4 Caribbean grandparents, which we had to make very explicit, included Bermudian. We had a lot of women that excluded themselves, saying they were Bermudian, but they were not Caribbean, so we had to clarify that. Then we had the control group, which had to have the same age, same ancestry, but they could not have been diagnosed with any cancer, which actually became the hard part, or any first-degree relative with cancer. So no parent, no sibling, or no children. So we actually didn't think we were going to hit 50 for that group. We said, if we make it to 90, it's fine. Get 40, that's okay. But we did actually eventually get there, but it really looked very difficult because, as you all know, we got a lot of cancer in Bermuda. So we had 2 main aims. The first one was, can we conduct a 30-gene panel locally? As you may know, the Bermuda Cancer and Health Center has been doing a genetic risk assessment clinic for about 17 years now, and they send all their samples away, and it takes between 6 to 14 weeks. It's very expensive. It is covered by insurance, but the question was, can we do it locally? Can we do it faster? And can we do it cheaper? The second aim was, at the cancer center, they keep a record of all the inheritance and the family trees and the pedigrees. And Dr. Hughes, who actually is the birth of this project back in 2019, he said to me, well, I've been tracking the inheritance of breast cancer, but when they do the test, it comes back negative. He's like, clearly something is being passed down, but we don't know what it is. So we decided maybe we weren't looking in the right place. Let's look for other genes. So can we find a novel variant that is not normally tested for breast cancer or may not be even linked to cancer at the minute? So this is how we got on. As I said, it took 14 months for ethics. We did eventually get it as of May of last year. We then took about 6 months for recruitment. And again, it was that last piece with the control group. We took 2 months for sequencing once we got set up and running. And there was a bit of a delay. We were actually done it in 5 weeks, but we had to wait 2 weeks to get more reagents. The joy of being in a small island, I was not used to that being in the UK. If you ordered it today, you got it tomorrow. My students were not used to that, so they were just going and going and going, and then had to order. So we're working with the company to make that a little bit better. And then analysis, so reporting back to patients. We use a software called GenX, which essentially uses the latest, they use AI to scour the latest literature, the guidelines, to find what is the latest in terms of these genetic mutations and annotate them or give them meaning. And so that helped us tremendously, because otherwise we would have been doing that manually. And we were able to do that in 6 weeks. And I will say, bless their hearts, this was when the college didn't have internet. So actually that took 3 weeks out of our 6 weeks. So everything went wrong with this project. This is also when the government got hacked. So our genetic nurse couldn't come down. And we had to do that remotely. So we made it through in under a year. So these are the participant demographics. We had a wide range of the community involved, which I was so excited about. The age range was from 19 all the way up to 84. The patient group and the control group, we did get equal. It was 51 in each. The mean, mode, and median ages, you can see, are not too far off. And the range at diagnosis was 31 to 74 for the patient group. And really was pleased that we had a mixture of survivors. So our oldest patient was 84, and she was 47 years a survivor of breast cancer. She did come to my public lecture in May, and she came up and gave me a hug. So that was nice. And she said, I want to just be able to help the next generation. And we also had current people that were diagnosed that also said, I want to help the next generation. And that was really, really got me. What was the consent rate? So we had to have informed consent for everyone in order to be in the study and to collect the blood sample. But there were additional consents that we wasn't sure what the rates would be. So one was to join our research database, and that means they can get their DNA in a DNA vault, which is on the blockchain, so it's a bit more secure. And all of them said yes to that, which we did not expect. We asked them if they wanted to get their results back, so either their breast cancer results or other cancer risk results. Not everyone said yes, but the ones that said no already had cancer for some time and didn't really mind to know how they got it. And then the last was to be recontacted for additional studies or further sample collection in the future. And all of them said yes. So we were so proud of that. Now, this also took place when 23andMe was hacked. So we kept getting questions in the consent like, well, where is my data? Is it going to the States? What's happening? And so we made sure that we gave that comfort that it was going to stay in Bermuda. And we partnered with both Engine and Corvardis, Corvardis being the data center in town. So we have all of the data in a private cloud here in Bermuda. So the sample didn't leave and the data is here. And so I was actually driving hard drives from the college to the data center. Hopefully one day we have a nice pipe that can do that for us. If anyone wants to give us money or invest, we will take that. But that would be a future goal. So what were the initial results? So this is what we initially had when we first did the analysis. We were expecting like a very low rate based on this paper that had been published in the past, but we actually saw about 20% of the patients, so just the patient group, not the whole 100, just out of the 51 women that have breast cancer, having a gene that was likely causing their cancer. Now what was interesting was out of the 51, there were different age ranges, and 36 out of the 51 were under the age of 50 when they were diagnosed. So that likely indicates that something is genetic. The longer you get, the more likely that you're getting something from birth. only 3 out of the 36, which is very low, had a genetic mutation. So we had one that was 32, or 2 that were 32, actually they both had BRCA2, and the one that was 37 that had BRCA1. None in the 40s category had any genetic markers. So when we took that to some genetic experts, they said, we're definitely missing stuff. That is way too low. And the fact that we actually didn't try to recruit for people under 50, that just happened naturally, also spoke volumes. So this is where we're at right now, after the discovery phase. So we have BRCA1 and BRCA2, as was mentioned earlier. We have BRIP1 as well. We actually had someone in the control group that also had BRIP1, so someone that didn't have any history of cancer. So now we have sent them to the cancer center to join their program to get screened. RAD51C, so we knew those ones. The ones under that, so FAN-CC, RAD50, RAD51, RAD54L, you can see in the pattern, RAD, and then TP53. So these are the ones that are not conventionally on your list, and we would have missed them if we didn't go digging deeper. So what about this RAD family, right? Because you saw they came out quite a lot. These are range of proteins involved in DNA repair. Actually, most of the genes that are linked into any cancer are involved in repairing the DNA when it's broken by whatever happens. Maybe it's the UV light, maybe it's something that's happened, maybe smoke or whatever the case may be. The DNA is broken and it can't fix itself. So this is what happens. So the RAD proteins were initially found in yeast and identified as products of genes that were very sensitive to X irradiation. Subsequently, they found them in humans. And we already know RAD51, C, and D, for any of those who are involved in cancer, they come up quite a lot. But the other RAD genes are not as common. And so we're seeing a lot more of those in our population, which is interesting. But what does that all mean? What it means that there are more therapeutic options than we originally thought. Most of the therapies are designed against BRCA1 and BRCA2, and you may have had a company come to the hospital that wants to work with you, a pharma company, because they have the treatment for BRCA1 and BRCA2. So guess what they want to do? Test for BRCA1 and BRCA2. That's all they care about. But we're showing that that's not good enough. We need to look beyond that. So we need to look at other therapies that potentially can help based on this new information. So the outcomes for this study was that we created the infrastructure to conduct the cancer panel locally. And we took that 14 weeks and we got it down to 2 weeks. And there's more. Oh, and it's cheaper. So if you think about it, it's actually cheaper for us to do the whole genome of that person. And you can look at the specific, cancer genes, than for us to send it away and to look at, I think it's 91 genes. Wow. Who would have thought? So put a pin in that. I'm going to come back to that in a bit. And then aim number 2, we have established infrastructure to be able to generate novel structural variant data and epigenetics. So normally when you do genetic testing, they look for, is one of the bases or the building blocks different? So that's like a small change. Because we're doing what we call long read sequencing, so a bit technical, we can actually see big deletions that are missing out of the genome, which you normally can't see. But those also can cause cancer. And we can look at inversions. So actually the first cancer genetics was 2 genes that were on different chromosomes and they caused an inversion, and that's where you got the cancer. So we can start to look at all of that. And you may have heard of epigenetics. Who's heard of epigenetics? It's like the new trend. Yes. So we can look at that as well. We actually generate that data at the same time as we're generating the genetic information. Technology we use is the only one that can do that. We're also able to check for novel variants, as I showed you, which is in progress. And we have had interest from pharma companies, actually more than one now, based on the merit of the study, the way we conducted it, how quickly it was, and we were told this is the only study that is known to have such pure ancestry from the Caribbean. So we are very proud of that. So this is the pioneering team. So you have Dr. Kevin Hughes from the Bermuda Cancer and Health Center, who is the brainchild. He actually reached out to me in 2019 when I was the Corange speaker at Bermuda College. This was February 2019, and I did a press article on, genetic testing would be great to bring to Bermuda. And he reached out and said, well, I do testing at the Cancer Center. When you set up, I want to send stuff to you. And here we are, 5 years later, about to make that happen. For recruitment, we have Nurse Kamini Fox and Nurse Philandra Costello from the NHS. the lab team that did all the sequencing locally, and our analysis from our bioinformatician and our genetic counselor, Sarah Beck, who we're going to put a pin in gently as well. Yes, I love this. Okay, so that is wonderful. We've done that, and now what? This is the vision. That was just the pilot for a bigger plan. So we want to do the Caribbean Genome Program, where we're looking to do 100,000 Caribbean people to do the whole genome by the end of 2027. This is to get us on par with everywhere else that's doing this. So the UK was the first to do a 100,000 genome program. The US, there's many different European countries doing it. Singapore has a genome program. Everyone has a genome program, apart from us. So we want to enter the chat and make sure that we are doing this because we need the data. So the next step here is we are doing our kind of proof of concept for the Caribbean. We've done this in Bermuda. Can we take this on the road? Can we replicate this in other Caribbean islands as well? And you can see I've made it blue, not by accident, because we're now focusing on prostate cancer, which is very much needed. So all the men in here, we're going to make you talk about your health. It's very important. Okay, so before I move on to the next section, if you would like to conduct a study with us, we are very open. We would love to work on any and every project that we can. We have funding, but we will ask for it. And if you would like, we will have a Carigenetics Clinician Network that you would have seen in your lovely online survey. If you would like to join, please let us know, and we will give you more details. Okay, so prostate cancer is even worse than breast cancer. It's horrible. To the fact that we know that, well, I know, men know even more, that you're not getting the test as much. You don't want the test. I'm not going to go into more details, but you know what I'm talking about. We are not in the Caribbean screening as much as we should, but we are top 6 of the top 10 countries getting prostate cancer. So what does that mean? We're not even looking for it as much, but we're still top of the charts. And when it comes to deaths, we are 7 of the top 10 countries in the world are Caribbean dying from prostate cancer. I have presented this in 2 of these countries so far, virtually in 4, and everyone was shocked that they were on the top 10 list. They didn't know. So we are on a mission because there hasn't really been a study. The only one that has been done is on unique genetic markers in tumor tissue from 25 men in the French Caribbean. That's it. So we need more. And I'm super excited that we have Dr. Jonathan McInjola here from the Daily Mail. We are partnering with the Daily Mail to do the Bermuda cohort of the Caribbean prostate cancer whole genome study. We recruited the whole control group in 30 days. So the men are not holding back. And we anticipate to start doing the actual recruitment and taking the blood samples in the month of November. We also have St. Lucia that we've applied to ethics. We have Antigua and Barbuda. We have Jamaica, Trinidad, Dominican Republic, and I'm missing one. No. Oh, whoever gets it right gets a prize. No, I'm sure. Hold on. Oh, Guadeloupe. You wasn't going to get that one. So we're really proud of this, and what we're finding is that, people are like, where have you been? You should have been here 5 years ago. Let's get this going. So we're really excited about expanding into this study. Now, what was interesting is when you do genetics, now you normally look at the individual, but you can actually start to do trios of families. When you start to do that, it's actually very powerful. So what you're looking at are 3 different individuals. This is what we call an IGV plot. It's actually the actual reads, so the actual sequencing you're seeing there. So each of those gray lines is a different read of sequencing. And you can see in that position that is highlighted that it's missing some of it, right? You can see that? Like the gray is like more than half. That's showing a deletion in that spot. The top is the mom. The middle is the dad. The bottom is the son. This is a Bermudian family. Now, the son and the dad are actually in our study. Happenstance that we tested the son for something else, and we found a mutation, and they have given consent to be in this presentation. And we thought, okay, obviously he got it from the dad, because the father has prostate cancer. So if he's got a gene causing cancer, he must have got it from the dad, obviously. Got it from the mama, who's never had cancer. who's never had cancer. Now, the question might be, well, is that his daddy? I just got that question. You didn't hear it, but I heard it. No. Well, I can say yes with very much confidence because there were other markers that the mom had given him and the dad had given him the other ones. So I was able to make sure that there was no doubts.
No woe in the family.
There was no woe. There's no divides. This is a trio. So this is a CHEK2 mutation, which we didn't actually find in the breast cancer trial. What was interesting is that the mom is actually not from Bermuda. She's from another Caribbean island. So we're starting to see, early on, and we're going to go through the 100 men, and we're actually going to do more than 100. We're going to do 150, because we're going to also include the group that's in the middle, which is men that don't have cancer, but have a first-degree relative of cancer, like this gentleman, because they actually need to know more than anyone else. Like, do they have a risk? So we're going to do 150 men in Bermuda. Okay, so every one of our participants in our studies, we offer a health and wellness test. This is another area that we've launched at Genetics, and we now have all 12 of these, so there's a few of them here. And there is a For You bundle, which you get 4 tests together. So you get fitness, nutrition, skin, and personality. That is what you're going to win tonight, based on the... Yes! So we have all of these, and we also have a paternity test at home. So you can take it at home, and no one has to know for sure. It's the name of it. And then we also have a family relationship test as well. Know for sure. You gotta know for sure. You will know for sure. I like a little name. Don't mind me. And I can say that we've interestingly had one of our first clients of the family for sure, so that's a family relationship test, use it to settle a land dispute in the BVI. So someone, had land, they passed away in the 90s, and then a son appeared, said, that was my daddy. Said, okay, so now he wants the land. But the surviving relative said, no. So we did the test. But this time for, not at home, because that's not chain of custody and all that. They actually did it for court admission. So you have to come, get a picture, see who's swabbing you, fill out more paperwork. And I won't say the results. Okay. Yeah, he's not getting the land. But it did. Well, no, I wouldn't say he's a liar, right? So, the mom and the guy were in a relationship, but it just wasn't. That wasn't what crystallized to making him. And what it gave a good. Sorry, I am a little bit of a comedian, just to say. It did give me a good opportunity though to educate. So I had to talk to the lawyer. I had to write. So we're talking about cool stuff earlier. I had to write. From my expert opinion, this person is not related. And just to say that DNA is very decisive. Up to a certain relation, it's almost 100. First cousins is 100% accurate. And so that's for us. These tests are actually a way to educate the community. Because if you talk to the community about genetics, they will say ancestry, paternity, and cancer tests. That's what we think about when we think about genetics. So our goal is to build that relationship with the community. Because genetics is not just about those 3 things. It can tell you what food you should be eating. Do you have a deficiency in iron? Are you a morning person? Are you agreeable? That's shout out to the personality test. Now, the other thing is that, we want to give information, and obviously as doctors, you have information, but you take it beyond information. You try to help implement it in your patient's journey. And so we have expert coaches and experts that work with us to make sure that happens. So we have Coach Alex, who will do all of the fitness, nutrition, and skincare results. And I will, not you filming. I'm going to call you. You already knew that's happening. And we have Dr. Matthew, who is here, who is our health psychologist. Yes. So she will make sure that those personality results will be implemented and you will have a plan of action of how to take that information, because the mental grind is actually sometimes harder. The barrier is sometimes harder to get past. So again, the winner of the prize, you will be getting this expertise as well. Oh Lord. And so the other thing, I know we heard about the 420 test earlier, that you have one here. It's not to test the strain of, that's not what we're doing. I get that question all the time. No. We are not doing that. We're all about testing people, right? So we're going to tell you, so from a medicinal cannabis standpoint, what should you be taking as a dosage for medicinal cannabis, or someone that's new to using cannabis, because it's going to be based off your body weight or your metabolism. You have enzymes that metabolize, is actually the same ones that metabolize your medication. So we can know based on genetics, like what strain, what level of strain you should be getting, what dosage you should be getting, so it can be more tailored. Okay, so that is what that is about, and we are proud to partner with the Bermuda Cannabis Association on this. They are committed to education, to collaborative work with others. So that was a question, or is a question in the survey as well, if you would like more information with them. Okay, so this is fantastic with the studies, the products, but what about everyone that wants to know their cancer risk? What about them? This is why you're here for the big announcement. Drum roll, please, yay! So this is our official launch of our clinical lab, Carika Genetics Precision Diagnostics. And we are doing genetic clinical tests on island for the first time. So we're really excited about this. I'm going to run through some of these products so you can understand them better. We are bringing genetic expertise to Bermuda. So again, genetics is even more complex because it can mean this in this context. And we want to make sure that when we tell you a result as a clinician, we're able to give you the full picture. So we have a multidisciplinary team, which includes a medical technologist, laboratory geneticist, genetic counselor, clinical geneticist, and clinical oncologist. And every referral comes through this team. We meet weekly, and every result comes through this team. So we will review everything. You have to. Because again, you don't want to give a result that says, oh, you should get, you should remove your colon. And it was just because someone misread something. Like, is that serious? To your point, with MRI and genetics, it can really tailor what you're doing. So we want to make sure that we're giving the right results. So we're really excited to partner with these multi-experts from the UK and the US. And I'm the Bermudian on the team. So we are going to be doing hereditary cancer. So there is going to be a form that you can use. We did actually decide this morning that we will take both referral from clinicians, but we will also take referrals from individuals. So they can self-refer. The difference is that we, from an insurance perspective, which we can get reimbursed from insurance, if it comes from a clinician, then we can take it to insurance. If it comes from self, you got to come out your pocket. So we're not going to stop you. But the other part of this is that you may not know, or the individual may not know what genes they should be getting. So everyone will have a pre-test consult with our genetic counselor, which is reimbursed by insurance. We do not need approval for that. And she will determine, yes, you have a family history, you should get BRCA1, BRCA2, check 2, and she will be able to order the test and give it to us in the lab. So that is the process that we'll have in place. Happy to answer any questions after this if you have them. We also are very excited to partner with the Poundbury Cancer Institute. Do we all know who that is? That's King Charles. So the head of the PCI is Dr. Corrado, and he is on King Charles' land. They work, he's top-notch, They are ISO 15189 accredited, and they can do the turnaround time for all general pathology and molecular pathology in 72 hours. So again, we are not doing this on island. We're sending it to the UK, but we're partnering with them because we want to make sure that people are getting good care, and we want to be able to give you guys information faster. We're also excited that they are happy to do training of pathologists. So we actually have the former CMO of St. Lucia, who is the consultant pathologist of our lab as well as his own lab in St. Lucia in the UK that did training this week. So if there's any interest, please hit me up. And the other key thing is that they're able to do internships for students, those that may want to go into this field, and they also do digital images. So you would get the actual image and you can add that to the medical record. Not just, the result, you can actually see it for the pathology. So we are very excited to offer that as well. Now into the actual test. So we have Early Insights, which is the prenatal, non-invasive prenatal test that women get when they are pregnant at about 10 weeks. It's a blood sample instead of amnio. They can get this blood sample and see the health of their baby. This particular test, you okay with me? Yeah? I can mention it? Go for it, okay? This particular test alone all goes through the hospital. So currently they get sent to the hospital to send away. And by us taking it on, and we already have insurance on board, that's always a key question, key part, it will add back into the kitty of the hospital. A 6-figure number. I won't say which number. But that now frees up resources so that, number one, the lab staff are not having to send these out all the time, at least for this test, and then there's more resources. This is my favorite one, actually. Pharmacogenetics. Has anyone heard about this? Yes. Good. So I actually gave a talk on this last year as well at one of the mental health conferences. And so pharmacogenetics is the study of how your genes affect how you respond to drugs. The goal is to maximize drug efficacy, minimize drug toxicity, predict the patients who will respond to intervention, and to aid in new drug development. So the cool thing is a bit of the technical side. It's linked to drug metabolism because it is testing for the genes that do the metabolism, the enzymes. And there's only about 6 of them, these CYP450 enzymes, that metabolize 90% of the drugs. So we can focus on those. And there are 4 different types of metabolizers. You have a poor metabolizer, an intermediate metabolizer, normal, and then an ultra-rapid metabolizer. And the frequency of which your group you're in actually is played on by your ethnic background. So for example, for this particular gene, you can see that some ethnic groups on the top here for poor metabolizer, you have Caucasians, you have Mexican Americans, are poor metabolizers. I think what stands out the most is the ultra-rapid metabolizers. You have Ethiopians, 30% of them are ultra-rapid metabolizers. So if they are given a certain drug that is metabolized by this, it's going to convert into the downstream product super fast. That is key when you're prescribing for individuals. So this is already used, pharmacogenetics, in cancer treatment. You might be familiar with the fluoropyrimidines. So this is an example. I thought I had to give a nice clinical situation. I'm not a medical doctor, but I said I need to give you. You appreciate it? Yeah, okay. I did try. So there's a 68-year-old man that goes to his GP with altered bowel habits and is diagnosed with a left-sided colon adenocarcinoma. The oncologist undertakes DPYD, so it's another gene that does metabolism, genetic screening, which reveals the patient carries a reduced function DPYD genetic variant. He commences chemotherapy, but at a reduced dose, and is cautiously incremented to 75% of the standard dose over subsequent cycles. So this is precision, it's tailored to that individual based on his genetics. So ultimately, pharmacogenetics can give better care for patients instead of this standard approach where you're prescribing medication, more one size fits all, it doesn't work, they come back, you give them another drug, it doesn't work, you have side effects, you give another drug, and we eventually, trial and error, end up at the right drug. We can just do a one-time test, pharmacogenetics approach, where you then know for certain this is what this patient needs. They get the right medicine at the right dose. It is a one-time test because your genes are not changing, and it can be done by a blood sample. And this is really the hope, or the hype, that you can go to the pharmacy, they would already have it in your record that you should get this dosage, and then they're giving you the right prescription. Well, the hope has arrived. Meds for you. This is our new product that you can order. There's 6 different versions. So we have one for diabetes medication, one for mental health medication, cardiovascular health medication, ADHD medication, pain management medication, and you can get a whole comprehensive version that covers all of them. And then the last one I have is the polygenic risk score. So it's called My Risk Score. And what it does is it measures different genetic variants and will give you your lifetime risk of disease. And it is actually calculated using your ancestry. So it compares you to people of your ancestry and tells you this is your risk of disease. So for example, it actually covers 15 different diseases. It will give you a percentile that you fall into. And that can then be used to help you guide what to do with your patients going forward. What we have decided as well is that anyone that falls into the breast and prostate cancer category, if they have above a certain percentile, we will then figure out what the gene is and take them over to our cancer panel test as well, and then be able to put them through the system. So, precision medicine has arrived. More of precision medicine has arrived in Bermuda. We have clinical studies, at-home wellness tests, hereditary cancer panels, early insights, which is our prenatal test, meds for you, and My Risk Score. And there we go. Now you can answer that question in the survey. Oh, it's questions? Let's do the questions. All right, I had a hand at the back first, and then we'll come to you. Oh, let's get the mic. Oh, 1 second.
It is my pleasure to thank Dr. Basin. Let's hear that, Dr. Weldon. Let's hear it for her. Thank you. We are so proud of her and her work, and I want you to know that all of Bermuda is proud of you.
Thank you.
Thank you so much.
Thank you.
Appreciate it.
I agree.